Hi, in this video I'm going to go over how to use your graphing calculator as it applies to sequences and finding sums. So first of all, if I have this sequence defined by this term, u sub n is 2 minus 4 over n. What I need to do first is put my calculator in sequence mode. So hit your mode button, go down and put it into sequence mode. Alright, so now when I hit my y equals button, I have a different looking screen here. It has a u sub n screen. Now because I'm going to start with n being 1, this n minimum is defaulted to 1. So all I need to do here is push 2 minus 4 divided by n. I can put parentheses if I want, but the order of operations will force the calculator to do 4 over n and then subtract that from 2. Okay, so I'm going to get out of that. Now, if I want the fifth term, let's say we're going to find the fifth term, u sub 5. I can calculate it directly, saying 2 minus 4 divided by 5, and I get 1.2. I can also use the trace feature. Now I've got this in my y equals screen, so I should be able to graph it. If I click on graph, it gives me the picture. Now I'm going to do zoom fit to give me a little bit better picture, hopefully. There you go. Because my index starts at 1, I don't need any negative x's. And when I hit trace, notice how n and x correspond. When I trace this going to the right, my n and my x continue to go up together. Now because I want u sub 5, I'm going to go over till the n and the x equal 5, and there's my y value. It's the same thing. All right, now I can also do a table. So I'm going to do second table set. I'm going to have my table start at 1 because it doesn't make any sense to do anything else, because I want u sub 1, then u sub 2, then u sub 3, and I'm going to go up by 1, and I'm just going to leave it at auto. So when I do second table, these are my values for n. These are my values for u sub n. So the fifth value is 1.2. And then the fourth way you can do it, if I get out of this, is to calculate it directly. So first of all, I'm going to hit second and then 7 because there's a little u there. When I use the second button, it's going to put my sequence's name on the screen. Now in parentheses, I'm going to tell it I want u sub 5, and I should get the same thing. I do. So once you have your sequence rule entered in here, you can do a lot with it. You can graph it, you can trace it, you can make a table, you can calculate any term directly. Now when you want to find the sum of a certain number of items or elements of a sequence, you can represent it in what's called sigma notation. And the way that that works is you have an index of summation, which is going to run from your lower limit to your upper limit. In this case, we're going to take terms numbered 1 through n, and we're going to find the sum of all of those terms. So let's take a look at an example. This sigma notation tells me to take all of the items or elements of this sequence, and I'm going to let I run from 1 to 5, and I'm going to add those 5 items all together. So the rule is take 4 times the index, so 4 times I. So as I runs from 1 to 5, I'm going to take 4 times I to get each term. So when I look at it, this is 4, this is 8, 12, 16, and 20, and that gives me 60. So the sum of the elements for I equals 1 to 5 of the sequence for I is 60. Now let's say I just wanted to find, let me change colors here. Let's find the sum for I equals 1 to 3 of 4i. Well, then that would be 4 times 1 plus 4 times 2 plus 4 times 3. And we know from up here that's 4 plus 8 plus 12. That would be 24. So I want to give you a little notation here because this would be considered the fifth partial sum. This down here would be the third partial sum. So let's consider the infinite sequence A1, A2, and so forth. If you want the sum of the first n terms, that's called a finite series. It's also referred to as the nth partial sum of this entire sequence. And whereas a sequence has the elements separated by commas, a series is the sum of the elements. So in this case, I've got the sum of the elements for the index from 1 up to n, which would be this notation. If you have an infinite sequence, so you have your terms of your series, but instead of stopping at the nth term, it goes on forever, then we say it's the sum for I equals 1 to infinity of my element, and that's called an infinite sequence, which when we put plus signs in between all the elements, that's called then an infinite series. So let's take a look at how you enter a sequence into your graphing calculator. First of all, you need to go to your mode, and then right now it's in function mode and we need it in sequence mode. So go down and across, highlight sequence, and hit enter. Now go to second quit and click on your y equals button. Notice that this is different. This is a sequence mode. So my rule, instead of being a sub n, it calls it u sub n. I can have a u, a v, and a w. So here's where I'm going to put my rule, and for this example my rule is going to be 2 to the n. So I'm going to click 2 to the n. I'm going to start with 1 in my sequence where n is 1. So I'd expect my first term to be 2 to the 1. If I wanted to start with a different index, I would change this number. Okay, so second quit. Now, second stat ops. You'll see option number 5 down there is a sequence. Now the arguments for the sequence function are the expression, the variable used, where you want it to begin and end, and what the increment is. Normally we would just leave that as a 1 because I want a sub 1, then a sub 2, then a sub 3, and so forth. And because that has a default on your calculator, you don't have to type it in unless you do want to change it. So my expression, I stored it in U, so the way I get that is I click second and 7, because notice there's a little u as my second function there. So that's u, comma, I got to tell it what variable I'm using, which is n, comma, let's do 1 to 5. Close my parentheses, and there's my sequence, the first 5 elements of my sequence. Now, if you want to, we'll do that second list ops again. If you want to, you can directly enter your rule. So I can say 2 to the n directly. I don't have to put it in u first if I don't want to. Comma, tell it the variable you're using, comma. Let's just do the first 4 terms on this one so you can see the difference. And there are the first 4 terms. Okay, let's say we want to evaluate this sum using this sequence. These are the terms we already looked at before, but now I want the sum of those elements. I don't want just the list of them like we did in the previous example, but I want to actually sum up the first 5 terms. So I equals 1 to 5. Here's a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. I should get 62 as my answer. To do that, we need to use the sum function. So on your calculator, you're going to go to second list again, but it's not in the OPS, the operations, it's in the math menu. So go over to math and you'll see it down here at number 5. Now we're telling it to find the sum, but now we need to tell it to find the sum of our sequence. So now I need to do second list operations. I'm going to choose 5, and then the rest is the same as we did before. I have my sequence already established in U, so I'm going to say second 7, which gives me U. Tell it the variable, which is n. I want it to go from 1 to 5, and I don't need to put the increment because I'm going to use the default of 1. So I'm going to close my parentheses, hit enter, and I get 62. Okay, here's a sequence that's defined by a sub n equals 4n. That's 4 times 1, 4 times 2, 4 times 3, and so forth. Here I have listed the first 5 partial sums. So for the first sum, I goes from 1 to 1, so I have 4 times 1. For the second partial sum, I goes from 1 to 2, so I've got 4 times 1 plus 4 times 2, and so forth. Now, if I want to find, let's say, the third partial sum, then I would go second list ops, over to math and choose the sum. Then I would go second list ops, pick the sequence. Then I'm going to put the rule in, since I don't have it entered into my y equals screen. I'll just say 4n, comma, my variable is n, comma, and I want to add the first 3 terms, so 1 to 3. Close my parentheses, and I get 24 because the third partial sum is 24. Now, if I need more than one partial sum, sometimes it's easier to use the cum sum function. So to find that, you go second list ops, there it is. And then you need to do second list ops again to choose the sequence. Then I'm going to do the same thing I did before. I'm going to write my expression, which is 4n, comma, my variable, which is n, comma, and I will list the first 5 partial sums, so 1 to 5. This lists the first partial sum, second partial sum, third, fourth, and fifth. Those match these numbers right here. So if you need just one finite partial sum, then I would recommend using the sum feature. If you need a number of partial sums, then you can use the cum sum feature on your calculator, and it will give a list of the sums. It's not the same as sequence, which just lists the items in the sequence. This lists the sum of the first term, the first 2, the first 3, the first 4, and so forth. So as a final note, here are the 3 functions that will help you. The SEQ, which is in second list ops, sum, which is in second list math, and cum sum, which is in second list ops. They will help you either list a sequence, find a partial sum of a sequence, or find a list of partial sums. Now I do need to just mention that this is what it's going to look like if you have a TI-83 or a TI-84 plus. If you have the color, the TI-84C color, you're going to get a different looking screen. Instead of getting SEQ with parentheses, you're going to get a line for each of these. It'll say expression, variable, begin, end, increment. Your whole screen will be filled with a line for each. Just fill them in with the exact same things that I did on this video, and you should be in good shape.